Alright guys, so we are getting down to the last sections of this unit. This should be your last recorded lesson you have to listen to, and then you get to hear me in person all over again. So, today we are covering AAS and ASA. Based on our previous days, you can probably guess what those stand for. Alright, and then we'll talk about that on the next slides. Okay, obviously that's our focus today. There's our standard, the things you'll learn. Same thing on your notes, da-da-da-da-da. Alright, so let's get down to the actual stuff. Alright, so again, since we're using angles, we're going to need to know that included angles are the angle between, so that's your fill-in word, between two sides. Okay, and it's really important that we pay attention to that. Okay, it's got to be between the two sides. Okay? Alright, so on this one, we're actually going to be doing included side. So the included side would be the side between, yep, you can guess it, two angles. Okay, so we're kind of flipping it around. Previously we learned that included angle is the angle between two sides. Now we're talking about, oh, apparently I can't spell. The included side is the side between two angles. So for ASA, if two angles and the included, actually I think I have it, oh, look at that. The included side of one triangle are congruent to two angles and the included side of the other triangle, then the two triangles are congruent. Alright, so go ahead and copy that in your notes. Feel free to pause if you need to. And on our picture, it's already labeled. Okay, so for the first one, oops, angle A is congruent to angle D. Okay, you can tell by the double arches in the picture. And the side between the two angles, AB is congruent to DE. Again, it's the little tapped mark. That's a side. And then the last angle, angle B is congruent to angle E. Okay, so you need to copy those into your blanks on your page. Once we have all those things, we can actually say that the two triangles are congruent. Okay? Alright, so let's move on to the next part. If you need to pause, do so. Alright, so let's get to the actual proofs. Okay, so I'm looking for ASA because I know that's what I'm practicing today. Alright, so QS bisects angle PQR. Alright, well bisects, remember that means cut in half. Hopefully that's what you were thinking in your brain, because we've talked about that a couple times today. We'll get back to that in a minute, but let's make sure this guy is filled in on our graph, or not our graph, our diagram. Alright, so PSQ, so PSQ would be this angle, and RSQ would be this angle. So in our picture, it was not labeled that they were congruent. So we need to do a little work. Put that in your picture. It's important. Do it. Alright, and then we have to deal with the fact that we are bisecting something. So it says that QS, let me get rid of my extra black lines that are unnecessary, tells me that QS is bisecting angle PQR. Okay, well bisecting means to cut in half, so just like when we do a line, it's going to cut this angle in half. Well, things that are halves are equal to each other. That means those two angles are equal to each other. Okay, now I'm not going to just use one arch because it's not the same as this one right here. I'm going to use double arches to show that they're equal to each other, but not necessarily equal to that other angle. All right, so we've got two things so far. Remember, if we're doing ASA, we need angle, side, angle, and it has to be the side in between the two angles. Okay, you can't just pick sides whatever I want. I gotta make it specific. All right, well, if this is my angle and this is my angle, okay, well, the side that's between them is the one that's connecting them. That's this one right here, which just so happens to be the same exact side in both pictures, which is what reason? Hopefully you're thinking it in your brain. If I say QS is congruent to QS, hopefully you're thinking the word reflexive. If not, you might want to practice that because we've been talking about it for a few days now. So that is reflexive. In other words, it's the same side in both pictures, or in both triangles, which means it has to be equal. All right? Well, we've got two angles, we've got a side. We have angle, side, angle. Therefore, we can say PQ congruent to RQS by ASA. You have to put that. You cannot just put that it's congruent. Every other day we've talked about this. You got to put the reason. You have to put the reason. Okay? So this is our reason. It's extremely important. If I don't put that, it could be SSS or ASS. No, it could not be ASS. Hopefully you thought that in your head. ASS is not one of the ones that we do, but it could be SAS. It could be SSS. Any of the things we've talked about. Feel free to pause if you need to write this down. All right, and then the other one we're talking about is angle, angle, side, abbreviated as AAS. You could probably guess that that means I need two angles and the side. This one is non-included. In other words, it's not the side between the two angles. Okay? And the corresponding two angles need to go with that, so go ahead and copy that down. And you can tell from the picture, it goes angle, angle, side. Angle, angle, side. It should match up with our acronym. Crazy, right? It works out that way. All right, and then of course, filling in our letters. Angle A is congruent to angle D. You can see it because it's got the double arches. And angle B is congruent to angle E. Those have single arches. And then the side, oops, apparently that's all of it. BC is congruent to EF. It's the only side we're looking at. It's more angles than sides for this stuff today. And of course, once we have that, we can say that the two triangles are in fact congruent. Pause here, copy down your notes if you need to. All right, so example number 2, now we're throwing in some symbols we've talked about a little bit in the other lessons, and we've talked about definitely in other sections of this year. All right, so let's make sure that these are actually marked. We've got RQ is congruent to ST. All right, well, RQ is here, ST is here. They've got these little tacked marks, so they are marked as congruent. Awesome. So I got my side. I just need my two angles. And this symbol right here, hopefully is going off in your head to tell you that it means parallel. Okay? That means you're going to be using those transversal things we talked about. We're going to be looking for alternate interior or alternate exterior or corresponding angles. Those things that we've talked about quite a bit this year. So just like before, I'm going to extend my parallel lines because I want to get a little bit better of an idea of this. So those are my two parallel lines, and I need a transversal. So I need a line to cut through my parallel lines, and it doesn't really matter which one I pick. I'm going to pick this one, so I'm going to extend this one as well. If you really want to, you can rotate your paper if that's a little bit easier for you to see. Okay, and I'm actually going to color in this line white. Don't do it on yours, but I'm just doing it to show you that if I eliminate this, there really is a transversal kind of stuck in that picture. Okay, so if you look at that, kind of turn your head sideways and look at it, that's actually our transversal, which means we've got some congruent angles in there. Right? So if I mark this one, because this one's gone now, okay, that one I'm not using. This one still has my two red sides, this one's still got my two red sides. They are congruent because they are what type? Hopefully you're thinking it in your brain. Think, 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 think. Okay, hopefully you said that those two, which we'll say RQU, is congruent to T, it's hard to see it, I think it's a T. Yep, it is. TSU, because they are alternate, which means on opposite sides of the transversal. Interior angles, because they are between the parallel lines. They are inside the two parallel lines. They're on opposite sides. This one's on the top, this one's on the bottom. So they're congruent. So I've got an angle, I've got a side. Well, we're practicing AAS, so I'm looking for another angle somewhere. So let's re-look at our picture. Now we've got all that stuff there. And I'll put my angles in that I just figured out. And hopefully you kind of had an alarm go off in your brain for the easiest angle. We've seen it so many times. Hopefully you're starting to see it before we even do the problem. If you take a look in the middle of the picture, this is known as the bow tie or the crisscross or the X angle. More formally, they are our vertical angles. So RUQ is congruent to TUS, and I have to say why. I cannot just state things whatever I want. I gotta actually say the reason. So you gotta say that they're vertical angles and that they're congruent. Okay? So now I have angle, angle, side, and I have angle, angle, side. Fabulous. I've proven everything I need to, which means I can say that my triangles are truly congruent. So I have triangle RUQ is congruent to triangle TUS, and I have to say that it's by AAS. Don't be tempted to write ASS, because again, that's a naughty word, and it's not really an actual thing that we can do. ASS does not work with triangles. They've proven it. Really, they have. It's a curse word and it doesn't work. So don't write it. Make sure it's AAS. I almost did that before. Pause here if you need to copy it down before we move on to the last example. Alright, so on yours, I know it's kind of hard to see. It prints in black and white, can't really do anything about it. Color costs $1 bajillion, so deal with it. Here's our lovely picture in color. Let's get a little bit of a real-world application now. So Jeremias is working with a community service group to build a bridge across a creek. This is how they do this stuff. When you create bridges, when you build things, geometry is everywhere. It's kind of crazy when you actually look at what they do. The bridge will span the creek between points C and B. So I'm going to underline some of my important stuff. It's going across the creek at C and B. Jeremias located a fixed point D to use as a reference point. So we'll underline that. So that the segments have the relationship shown. A is the midpoint of CD. That's really important, hence why I'm underlining it like crazy. And DE is 15 feet. Now let's check our picture. Is that actually labeled? Hey, look at that, it's not labeled. Let's label it. And actually we'll do that in a second. Alright, and then let's finish. How long does the bridge need to be? Alright, so right now it's kind of jumbled in a picture with color behind it. I don't really like that. So I'm going to redraw my picture out here. It doesn't need to be perfect. Really don't care if it's perfect. You just kind of need to get the general idea. Ooh, that was bad. Okay, so it doesn't need to be perfect, but it needs to be at least decent. Right, so hopefully you do yours better. Let's try this again. Alright, so it's not perfect still, but it's pretty close. It's close enough. Actually, it's not, because I definitely drew that wrong. Let's try this again. See, this is why you gotta pay attention to your stuff. Alright. Okay, now I got the picture of it. So we've got, so this is our right angle, so that's why I had to redraw, because C and D are right angles, and then kind of do this little thing. There we go. Now we got our picture. I've got B, I've got A, and I've got D, and I've got E, and C. Well, in the directions it tells me DE is 15 feet, so let's mark that up. And it tells me that A is the midpoint of CD. Alright, well if A is the midpoint, hopefully in your brain you're thinking the things that I'm thinking. That means that it's cutting CD in half at this point, and that means the two halves are equal. So this should be congruent to this. I'm going to write that off to the side for myself. And it's congruent to AD by definition of midpoint, just so I can practice putting my reasons down. Alright, and I've got two right angles here, so those are definitely equal to each other. Okay. Hopefully you're seeing something in the picture that we just did an example on. If you look in the middle, I've got some vertical angles in there just like before, so those are congruent. Okay, so now I've got angle, I've got a side, and I've got another angle that's congruent. I've got an angle, a side, and another angle that's congruent. So ding ding ding, the two triangles are congruent by ASA. How long does the bridge need to be? Well, if DE is 15 feet, and that means BC is 15